Dear friends, welcome to Infos. Welcome to another video from Infos and Oil and Gas Training. This is valve part number 11. In last video, I just noted that one, highlighted that one about the importance of positioners in control system or control valve and actuation system. So this video we will discuss about positioners and other accessories using in actuation system. Welcome to this video. A valve positioner is a device used to increase or decrease the air load pressure, driving the actuator until the valve stem reaches a position balanced to the output signal from the process variable instrument controller. You can see here the control signal is receiving to the positioner. The positioner is adjusting and providing the necessary power to the diaphragm or actuator. That is the one of the important use of application of the positioner. This is the positioner. This is the control valve. This is the valve body, and this actuation system, and this is the positioner. A positioner for a control valve is used to adjust a valve position based on a desired set point from a process variable, whether it is pressure, temperature, flow and level. So it is connected to the positioner receiving signal from controller and based on the set point of the process variable pressure, temperature, flow and level. A positioner is a device attached to an actuator that receives an electronic or pneumatic signal. That is important. Either electronic or pneumatic signal can receive from a controller and compare that signal to actuator position. If the signal and the actuator position differ, any difference is there, the positioner send necessary power usually through compressed air. That is the power it is producing. So separate compressed air signal also it is receiving to move the actuator until the correct position is reached. Affixing the positioner to the actuator allows the positioner to measure the stem travel in the linear valve or degree of rotation in rotary valves. This also changes the position of the valve as required based on the input signal from the instrument controller. When the process variable differs from the desired set point, the instrument controller sends an electrical or pneumatic signal to the positioner. This varies the pneumatic output to the actuator to move the valve open or closed accordingly. This occurs until the process variable reaches its set point. Controller is always trying to keep set point and process variable manipulated variable or process variable coming from the field to be same. So it will be always keeping the minimize the error and keeping the both variables should be same. That is this occurs until the process variable reaches desired set point. A pneumatic valve positioner receives here type of positioner. We have three type of positioner is there. Normally the common one is pneumatic type, little bit old one. A pneumatic valve positioner receives a pneumatic signal, typically 3 to 15 or 6 to 30 psi from a controller. You can see here the pneumatic controller is there. From the pneumatic controller the signal coming, pneumatic signal is coming directly. It is then supplies the valve actuator with the correct air pressure to provide an accurate valve stem or shaft position proportional to the pneumatic input signal. You can see here this is the type of a pneumatic valve positioner. Little bit old one, but still it is using in many of the industries. Another one is electro-pneumatic positioner, sometimes called abbreviated EP positioner, most common one nowadays, receiving an electrical signal, typically 4 to 20 milliamps or 10 to 0 to 10 VDC from a controller, and it then send a corresponding pneumatic signal to a pneumatic valve actuator. EP valve positioners may also referred as analog positioners. This is because electrical input to the positioner is an analog signal. Since many processing units use electronics with a 4 to 20 milliamp DC to modulate control valves, the positioner must convert electronic signal to pneumatic controller. In this case, the control valve is and actuator is pneumatic signal receiving. So in this case, the positioner itself is a converter, I2P converter, transducer is there. So it will receive electronic signal 4 to 20 milliamps, and it is compare and it is connect with the pneumatic signal also, and it produce a equivalent pneumatic signal as to the control signal. That pneumatic signal is going, so transducer is inbuilt. Otherwise, in other cases, a transducer is, if the electronic signal is coming from the controller, we are providing a transducer in between. That we are mentioning in our coming slides. Another type is a most modern one, digital valve positioner. Also receive electrical signal, typically 4 to 20 milliamps, but it is digital as opposed to analog. It sends a corresponding pneumatic signal to pneumatic valve actuator. In both, only in pneumatic controller is there, mean no need I2P transducer, and in other analog and digital controller or like PLC, then positioner is in case analog and digital or digital type or electro-pneumatic type means both we have a transducer is required to convert the electrical signal 4 to 20 milliamps to 3 to 15 psi. It also differs an EP positioner because it uses microprocessor to convert the control signal and perform the position control rather than a mechanical beam, cam and flapper assembly found in EP. That is the constructional details, but the microprocessor is there in digital positioner. This electrical input allows more advanced capabilities for the user. These digital smart positioners also collect data, automatically alert users about valve performance, diagnostics and maintenance. When a position signal is sent from a controller, positioners can receive either electronic signal with ranges 4 to 20 milliamps, this is very important, and pneumatic signal 3 to 15 psi. The term range is used to show the region between the lower and upper signal limit. A span is defined as the difference between lower and upper limit of signal. For example, a range of 3 to 15 psi means the span is almost 12 psi. Positioner operation. Positioner is based on balancing the force between the incoming signal from the controller and the actuator positioner. In other words, the positioner works to balance two forces. The force proportional to the incoming instrument signal, and second, the force proportional to the actuator stem position. An incoming instrument signal is received by the positioner in a milliampere signal. A conversion to a pneumatic signal must take place through the use of transducer. As I told in just the previous slide, the importance of transducer. Electronic signal is receiving from the controller. So actuator system is pneumatic. Then we need an I2P converter. That is called a transducer to convert electronic signal 4 to 20 milliamps to 3 to 15 psi before sending to actuator. So transducer we will quickly provide some information, and details are coming in later sessions. The transducer consists a feedback here. This is a transducer. I2P converter commonly calling. In PID it will write that one I2P. I/P. feedback look of a pressure sensor, electromagnetic pressure modulator, necessary electron is creating a proportional air signal to positioner. So one side it is receiving electronic signal from 4 to 20 milliamps from a controller and producing a equivalent pneumatic signal to positioner. That is the purpose of application of I2P or converter or transducer. The transducer can also include a small air regulator that is also possible to assist in providing proper air pressure for the pneumatic signal. If the positioner accepts a pneumatic signal, the signal is sent directly to the positioner. As the pneumatic signal changes, the air pressure inside the instrument signal capsule also changes inside the positioner and the air signal to the actuator changes accordingly. This is I2P transmitter. Transducer. This one, 4 to 20 milliamps, this one. So it's from the controller, 4 to 20 milliamps is coming and it is providing the output to air supply also there. It is giving the supply to either directly to actuator or that is very rare and it is giving to the positioner, then it will give to this one and air supply is here. The change in air pressure to the upper and lower chambers of the actuator causes the actuator stem to move either upward. Now our positioner is already given the power, air power, compressed air signal to actuator system. So how the actuator is moving, providing the enough power to the stem and the valve body. Ultimately our aim is to open the close the valve. The change in air pressure in the upper and lower chambers of the actuator causes the actuator stem to move either upward or downward. The motion of the actuator stem is transmitted to the positioner through some type of internal or external linkage or lever. As this feedback motion is received by the positioner, the stretch and force of the feedback spring are increased or decreased, which changes the counter force to the instrument signal capsule. External failure system, some of the other informations also like a fail safe and fail close facility. So how these are working in a actuation system. In some situation, the condition of a service are greater than the capability of an actuator fail safe spring. In case air fail, power is failed from actuator or any ESD emergency shutdown system, air is purposefully failing to provide an information to control valve or actuation system to fail safe mode for the safety operation. So in other application, an actuator with a heavy duty spring may not be practical either mechanically or economically. In that case, an external failure system like a solenoid valve or other type of system we are providing, like an air spring, we are using that one, may be added to the pneumatic actuator. So that will solenoids are sometime providing connecting with the electrical system, so that electrical system connecting to ESD. So when the ESD is activated, that is emergency shutdown system activated, so electrical power failure is taking place and electrical power is connected to solenoid. Solenoid is a magnetic operated. So magnet will go back to its original position, then the air supply line is closed and no more air going to the positioner and actuation system, then it is again going to failure mode, air fail to close or fail to open. This information I have explained in many of instrumentation module. Please have a look that one to understand more on failure system. An air spring is a self-contained pressurized system that has enough pneumatic power to force the closure element to move a particular position when the actuator power supply is interrupted. That is also possible. Here it is their signal to open, fail to close this is, and this is fail to open. Both cases there. Here the air signal is from the up and the piston is in the bottom. Here the piston is there in the top. Air supply. This is failed to close and this is failed to open. In most cases, this failure action is close to the valve. Most of the ESDs are considering design in that way, although some application exist that require a fail open action also. The volume of air required for this action can sometimes be provided by the actuator or in other cases by an external volume tank. Common accessories also we have to explain. Part of this actuation system. Let us see one by one. Some special actuation system or actuators require fast stroking speed, signal conversion from one medium to another, position transmissions. In these etc. In these application, accessories are included with the actuator to help perform these special functions. Filters, pressure regulators, limit switches, proximity switches, position transmitter, flow boosters, solenoid, quick exhaust valve, relief valve and transducers are common accessories part of actuator or actuation system. Filters, one of the most basic accessories of actuators, whether pneumatic or hydraulic, is the filter. This is the filter. What is the filter? Is normally using for clean the incoming air. The filter is designed to screen the power supply medium of impurities or other foreign fluids or object that may contaminate the actuation system. So air should be dry, clean and free from the debris. So whatever the input is going to the positioner, the air should be clean. So that's why we are using a filter. Filter and regulator together can use, or filter separate and regulator separate. Both different system can use. Actuation system, a positioner or other necessary. So it is cleaning the medium and cleaning the medium. Filters are installed between source of power supply and the actuator or positioner. Here, see the positioner and actuator here, power supply here. This is the filter. Filters have either a filter cartridge that has a minute opening or a series of screens. Sorry. These filters or screens trap any particles of a larger diameter that can clog the inside small passages of a positioner, foul a metal moving part such a piston, damage an elastomer such an actuator stem string. So if no filter is there, our source of power air will be fouling, or it will be wet and not clean, contaminated one. So it can damage the system easily. So this is the filter close photo and image, and this is the system in a diagram. Because compressed air, especially in humid environment, has a tendency to produce water condensation, air filters have a drip well and a drain valve to allow for draining any water. Here, see, here we can collect some drain, whatever the available water or liquid you can remove from here. Water can foul the passageways or in a positioner to cause both bacterial growth that can lead to erratic performance. That also bacterial corrosion also can develop. Next one is pressure regulator. So regulate the pressure. A pressure regulator, also known as air set, is used to regulate or limit the air supply to the actuator. This is the picture of that one. This is a system. While many plants provide air pressure between 60 to 80 psi, some actuators cannot operate at such pressure without an internal failure. So to increase and decrease, or better to say regulate the air pressure to the actuation system. Single acting actuators are limited to the lower range of air pressure, usually 40 to 40 psi and require the installation of pressure regulators. Limit switches, next one. This is the limit switch picture. When an electrical signal must be sent indicating an open, closed or mid-stroke position of an actuator or valve, an electrical switching device is called limit switch is used. So limit switch is providing the position of the current position of the valve opening or closing or mid-stroke or actuation system or the opening condition sent back to the control room to identify that when the valve opening or closing, the correct exact position, present position. That is why limit switch is using electrically operated. Limit switches are normally used to sound alarms or operate signal light, electrical relays or small solenoid valve. This is another picture of a limit switches. Limit switches are mounted directly to the actuator or rotary transfer case and use energized arms to make a connection with the moving stem or shaft through a stop plate or similar device. Position transmitter, almost like limit switch. Position transmitter is a device that provides continuous signal indicate the position of the valve or actuator, allowing the signal indication, monitoring actuator performance, logging data or controlling associated instrumentation or equipment. Solenoids, one of the important item, another one, this is a solenoid and this is the air pass and this is the electrical connection with a magnet, energized magnet. This is one closed image of the solenoid. A solenoid is an electrical control device that receives an electrical signal, usually 4 to 20 milliamps, and responds channels air directly to the actuator. This also solenoid also using in fail-safe and fail-open system to provide that one air control in case of electrical system fail on ESD. Another one is safety relief valve. It is also safety relief valves are designed to open to atmosphere when a particular pressure is exceeded. When volume tanks are used or if high pressure actuators must be used to handle the service condition, safety relief valves are important to protect overpressure in the instrument air supply. Any overpressure protection is there in the system, so it will release the air to excess air to atmosphere. Transducers, some more information on transducers as part of accessories. Transducers are electrical devices that convert an electrical signal to pneumatic signal, which may be required to operate a positioner with a pneumatic actuator. This is a transducer symbol picture. Here the I2P converter. Transducers have become more commonplace as the popularity of I2P signal has increased with newer control system, and existing positioners must be converted from pneumatic to electrical signals. Here you can see here the controller producing and electronic signal 4 to 20 milliamps up to I2P converter or transducer. Then transducer is producing pneumatic signal. See that dotted line is representing in P and ID as electronic or electrical signal, and here it is a long line with a cross in between different interval. This is the pneumatic signal symbol, and it is written here I2P converter. It also written here I2P converter. Normally in P and ID, Y is the notation using the word using for a transducer. So the signal is going to the control valve. See here, control valve is here and pneumatic signal is going. So it's a simple explanation on transducer. If you have a chance to review the P and ID and field visit, please have a look on transducer and positioner and understand the features what we have discussed here. The most common transducer is one that converts 4 to 20 milliamps to 3 to 15 psi pneumatic signal. Transducers can be mounted directly on the actuator or installed separately. Thanks for watching this video. Next video coming is regarding some more information on process control, like analog and digital process control from the field instrument, how the information, the signal reaching to the controller and control room like SCADA and DCS and PLCs, how it is coming. So, and return also from PLC and DCS and SCADA, how it is going, the output back to the field based positioners and actuation system and in the control valve, how these systems are working. Let us have a look that one, understanding some basic minimum information of process control like analog and digital control. Thanks for watching this video. Have a good day.